Let's ask a question. What if we could make the food and medicine we need differently?
No, this isn't science fiction. It's the incredible promise of something called precision fermentation. This is happening right now. So let's break down how this technology actually works. Think of it like this. We're basically programming microbes to be tiny factories for us. And the range of products here is incredible, from food ingredients to essential vitamins. But there is a big catch. While the potential is huge, scaling this up is a major challenge. The process has three main stages: upstream growing, harvesting, and then downstream purification. See, these living cells are sensitive. Small changes can lead to huge problems with consistency. So what's the solution? A smarter way to manufacture, using something called PAT.
This is a huge shift. We go from working in the dark to having a live, continuous view.
Especially those inline sensors. They're game changers, offering a live window right into the process. PAT is basically the eyes and ears inside. Now let's look at the actual tools. First up is NIR. It uses light to get a chemical snapshot of a sample instantly.
Then there's Raman spectroscopy. Think of it like a high-res camera for molecular fingerprints.
These tools are already used in pharma to save time, cut waste, and guarantee quality. Okay, check this out. This graph shows PAT in action, pinpointing the perfect time to harvest. That precision helps create more sustainable, more economical alternatives to chemical synthesis. Now, why does all this matter? Well, global food demand is projected to jump 56% by 2050. We absolutely need new, efficient ways to produce food with a much lower environmental footprint. And get this, the applications aren't just for Earth. We're talking about growing food in space.
This really unlocks manufacturing in even the most challenging environments you can imagine.
So now that we can program cells to make almost anything, what should we create next?